just let's discuss it in the break or after the session. Right, guys. So, as you guys are well aware, before we broke for test week or our test weeks, we covered the theory side to learning unit 6. So now we want to start doing exercises out of learning unit 6. So for your homework, where's my textbook? I want you guys to go and do this. Please go and do this because it is coming in the exam. Notice I did not say I think. I said it is. Please go and do question 6.3. That is decision trees. Remember the unit 6, 7, and 9. Unit 6, 7, and 8. They did not ask you those in the test. So where else can they assess it other than the exam? And particularly decision trees. This is the type of question that they ask people who get distinctions for the module. This is the distinguishing type question, and those that don't. Okay? But either way, it's better to know it because if that's a question that's very likely to come, guess what? There's a high probability that knowing it will aid you with your final mark, isn't it? It only makes sense, right? So let's do ourselves that favor of preparing for that particular question. Okay. Right. So I want us to do 6.1. And then just remember for homework, please, we want to dedicate the whole of Wednesday when I see you to that. And then I see you again on Friday, right? Thursday, yes. But I do see you before the end of the week. Sorry. Yeah, Friday I'm never here, so definitely out of the question. You guys don't want to do finance on Friday?
No, we don't do uni in general. It's been like that from last year, and we'd like to keep that.
So we see you Wednesday and Thursday.
Yes. So Thursday I should have your scripts. I'm sure they will be certified. Okay. All right. So are we all at 6.1? Let's see what's going on over there. 6.1. So today I want us to do 6.1 and I want us to do 6.2. So 6.1. Under the requirement, it says identify the best plan for utilization of the 7,500 machine hours, including commentary on the selling price that offers the highest expected annual contribution. Okay, so we know exactly what we need to do. We need to find out which plan best utilizes our machine hours. Okay, and then we obviously need to comment on the selling price that offers the highest expected annual contribution. Okay, so let's see now what's going on there. It says DASI Ltd is considering manufacturing and introducing 2 new products into the market. The research division of DASI has provided the following cost specifications for the 2 products. Okay, so we have direct materials, direct labor, factory overheads, and then we have the total unit cost. All right, and there they say 3.75 Rand per direct labor hour and 3.75 Rand per machine hour. Okay, so that will help us to find out how many hours, whether it's direct labor hours or machine hours, do we use for product 1 or product 2. Okay. Then it goes on to give us the following. It says the sales department has provided the following estimates and probabilities of demand and sales prices. Okay, so we've got the low price alternative. Okay, so remember, what is the unit? What's the title of the unit that we're doing? Expected value theory and decision trees. Isn't it? Okay. Does any of you remember what expected value theory is all about? You forgot. Okay, very honest answer. Okay, so expected value theory, we are trying to remember in statistics, which you guys did last semester. We use probability to assess the likelihood of outcomes. So we borrow from that, and we now are saying, from a financial standpoint, what do we expect to receive if we go with option A or if we go with option B? If we go with scenario A or if we go with scenario B. In this case, they are saying if we go with the low pricing alternative or if we go with the high pricing alternative. So we want to find out the expected value that we're likely to realize. Because remember, when we say probability, there's no guarantee that these particular outcomes are going to happen, is it? Okay. So that's why we say expected value theory. Okay, anyway. So there you can see, with the low price alternative, the selling price per unit is 150 for product 1 and 75 for product 2. And there you can now see demand estimates. Okay, so pessimistic 0.25, all right? And then there you can see the demand. Then likely probability 0.55, and there you can see the demand 2,500. And then optimistic 3,750, and the probability there is 0.20. And obviously for product 2, it's got its own separate demand. All right, same thing now, but now for high price alternative, the selling price per unit for product 1 is 160, and then for product 2 is 90. So you can already see the price has increased. And then also, if you look at the demand, just if you quickly scroll through those, you see what happens. You can see the trend is the demand what decreases. Can you see that? Aha. Okay. Right. And then there you can see total unit costs. All right. All right. All right. Then it goes on to say demand estimates are independent of the two products. The factory has a maxi min of 75,000 machine hours available. Sorry, that's maximum, sorry. Of 75,000 machine hours available. Historically, the company has worked at 90% capacity in making standardized product Z, which is highly profitable. Okay, right. Then it goes on to tell us on the next page, the maximum availability of spare machine capacity for the new product is 7,500 machine hours. The actual level of demand will be known at the time of production. Okay. An investigation of fixed costs of the past year have revealed that factory overhead is a linear function of machine hours worked. So basically they're letting you know factory overhead is based on machine hours worked. The monthly fixed cost is estimated at 12,500. Okay, so there's our fixed cost. And then it says the variable cost at 1 Rand 25 cents per machine hour. 1 Rand 25 cents per machine hour. Okay. Right. Nothing else there that they have for us. So again, our focus here is to find out how to best utilize this 7,500 machine hours. So you'll see I filled out and left a lot of the stuff here because these are things that we have done. So there's no point in wasting time on redoing what we have already done. So here we were looking at the unit variable cost for product 1 and product 2. Okay, so we were given the direct materials, we're given the direct labor. We did not have the variable overhead, but we knew that the variable overhead was based off of the, what did they say here? They did explain it here. Variable costs at 1 Rand 25 per machine hour. Okay, so we obviously would have needed to find out how long, how many machine hours do we require for product 1 and for product 2. And if you go back to the initial table on the factory overheads, we know that for product 1 it was 22 Rand 50, right? And they said 3 Rand 75 per machine hour, isn't it? So to find out the number of hours, we simply say 22 Rand 50 divided by the 3 Rand 75 to find out the number of hours, then times your, what rate is this? 125 for your variable cost, isn't it? Okay, and there you get your 7 Rand 50. Okay, and then you do the exact same thing for your product 2, and then you get your per unit cost for those respective products. Now that you have the respective cost, okay, you then go on to find out the maximum possible production with limiting factors. Okay, so I actually would have gone on to get this. This is where I actually probably would have. First gone. But I guess in this question it's sensible to start here actually, because you got two selling prices. You got the low and you got the high. So that's fair. So the maximum possible production with limiting factor, that being your machine hours. So here, first things first, we know that we are limited to 7,500, right? And we know that it takes us 2 hours to produce product 2, okay? And it takes us 6 hours to produce product 1, okay? We actually did this calculation in the previous section, okay? But here now we're just writing it out because there we were calculating the variable cost, okay? So there, now we divide those number of hours, right, per product by the, sorry, we divide the 7,500 by the number of hours to produce one product, right? And then we obviously get, okay, so the maximum number of products or units that we can produce with product 2 is 3,750, whereas with product 1 is 1,250. Why are we doing this? This is actually very important. Before we even go into looking at our two alternatives, why are we actually looking at the maximum number of units that we can get for product 1 and for product 2?
To ensure we use the 7,000, well, the maximum of 7,500 hours accordingly. So we don't want to be spending too much time perhaps on a product that's not going to be yielding us enough profit.
Yes, the ultimate goal is to calculate that. But before we even get there, we need to know that, because if our demand, for instance, if we look at our demand, is there ever a time where we say that we're going to have more than 1,250? Look at the alternatives, guys. We're all discussing this. Product one, is there ever a time where we say our demand is greater than 1,250? In either of those scenarios? Is there? There is. If you check there on, yeah, most of them, you see? So we're basically saying if ever we get a situation, now because we haven't yet applied the probabilities, that might go down. Because remember, when we apply the probabilities, we're getting the weighting. So we'll say 0.25 times 1,250 on the lower alternative, right? And then we'll say plus 0.55 times the 2,500 and add all those together to find out the demand. But if we find ourselves in a situation where either alternative gives us more than 1,250, we cap at 1,250 because we can't even produce more than that. Does that make sense? So that's why it's necessary to do this before we get into our alternatives, as you will see. So now that we have that information, we can now look at our first alternative. So the lower price alternative, this is all given information. The only thing we calculated was the variable cost. Yeah, we calculated the variable cost per unit up top here. Can you see in blue? So that just becomes a copy and paste. And then now we're calculating the contribution margin per unit. Okay, so they gave us the selling price minus the variable cost, and there we go. We have it. Then we now want to see probability distribution for product one. Okay, and this is now what I was now talking about. Okay, where we're saying now we have to calculate. And I want you guys to calculate. Contribution. Someone switch on the heater. Who is trying to cook us? It's not even on. So here, what are we doing, guys? We're saying? Yes, 1,250 times 0.25 to find out the probability here. We get that, and then do we leave it at that? This is product one, isn't it? Do we end off there? Okay, yeah, we can do that. So here we're saying 2,500, okay, times 0.55. And here 3,750 times. So what do they mean by contribution? This one.
1,250.
Where am I? Yeah, how did they get their contribution here? I think so.
Back to doing something different.
Mm-hmm. Just give me a second here. Oh yeah. I think that's exactly what. Yeah, that's exactly what they've done. 40 times. I'm just doing it mentally, but let's double check. 40 times 1,250 should give you that 50,000.
Yeah.
Do we have our calculators?
It's 100K for the next one.
So that means that what they've done is, yeah, they're doing something different from what I've done here. I'm actually calculating the final answer. Sure. If we're to follow this, because basically what they've done is they've said 1,250 times 40, you get your 50 here.
Yeah.
Then they're taking the 50 and timing it by the probability and then getting the expected value. Is that right? Yes. So, because, yeah, that is what they're doing here.
So the first one would be 12,500.
So, but I think, let me just do this because I want to see, did I maybe do things differently from the job? Yep. So that's how they're getting their. That's how they're getting their. So maybe let me just discuss these ones here. Because remember what I explained earlier, where we said the demand, we only have the ability to meet 1,250 units for product one. So even though there's a likelihood that we can sell more than that based on our research, market research, we're capped at due to our limited resources.
So I made a mistake. I was working off it.
Yeah. I jumped the gun. We weren't supposed to be using probabilities until we get to the workings here. So, yeah, but this is what I was saying, that if you can still get to the same final answer, because what they're basically doing here is applying the probability after we've already times the contribution by the number of units. What I was doing was timesing number of units first, then I was going to. So yeah, but it's fine. So is it making sense, guys? Are we together? So what we then have to do, okay, I wanted us to obviously be doing this together step by step, but we're here now. So we've put together our probabilities and we've got our demand at the different probabilities, okay? Or you can even say that the other way around. We've got our different levels of demand and their probabilities. Then we go on to say, okay, what is the contribution based on these different levels of demand? Okay, so we take, for product one, we know that our contribution margin is 40 Rand. So 40 Rand times the demand that we're likely to have. Okay, we do that for each of them. But here, this is what, who was asking the question? You were just asking the question now. To say, how come we have demand of 2,500, but we're only timesing by 1,250? And it goes back to what we established earlier over here, which is highlighted in, the text is in red and it's highlighted. we only have capacity for 1,200 units for product 1. Okay, so that's why we're timesing here by 1,250 instead of 2,500. Okay, once we have the contributions for each of the demand levels, we then say times the probability to get the expected value. Okay, and when it comes to the expected value, it is the sum of the different weights. Weights is the same as saying the sum of the different probabilities. Okay, so you add all these together, and that's how we're now getting 50,000. So under the low price alternative, we're basically saying we expect that we are likely to get 50,000 for product 1 under the low price alternative. Okay, again, it's possible for us to earn more. This is an average. Does that make sense? Because there is a chance that we might get, well, in this scenario where we're constantly capped, okay? But if, let's just imagine for a second that we didn't have that limitation of 1,250. There is a likelihood that we could have demand for 2,500, for instance. Does that make sense? It's a potential outcome, okay? So if we were uncapped, that means that we could sell up to that amount, which means if we were selling more than that, chances are we could sell more than this 50,000. So this, all that I'm trying to emphasize is the 50,000 is an average, okay? It's an expected value, so it's an average. Okay, but anyway, we then move to product 2 and we do the exact same thing, okay? But this time we must remember there we're capped at 3,750, okay? So again, our contribution there was only 17 Rand 50, okay? We get our contributions, and then contributions times the probabilities, and there we go, voila, we have our expected value for product 2, which is then the 65,000. Okay, and if you add up all your probabilities, it will always add up to 100%. I'm sure this isn't brand new to you, but just to recap, just a quick check to make sure you guys are doing the right thing. So this question wasn't too complicated. They then went on to basically request you to do the very same thing, but now obviously just under the high alternative method. Okay, so what I want to just do here is I just want to remove this. Or better yet, let me just do this. I just want to remove this and.
So you suggest doing it in 2?
Yeah, I prefer doing it in 2. I think when you do it in 1, it's very easy to start confusing numbers, and
it's easier looking at it.
It's easier looking at it, you see. Let's do that. Okay, so here now you can see. Again, we start off by calculating our contribution per product. Once we have that, we then say, okay, cool. What's our demand? Our different demand levels. Okay, the probabilities. Again, here we didn't show the working. However, again, they've said 625 times your 17 Rand 50. Oh, here it's actually 32 Rand 50. Sorry. Oh no, this product 1, 50. So times your 50, and then that's how they're getting the 31,250. And then here again we're capped at 1,250. So 50 times your 1,250, that's how they're getting the 62,500. Okay, important that you write this down, because I can tell you now, even in the back of your textbook, they don't have the working, right? Okay, so I hope you're not just following, but actually writing down, because it makes sense when we do it together, and then when you're at home alone, it's like, what?
But we have the recordings.
Ah, yeah, must be nice. Must be nice. Okay, and then here you can see the demand is 1,875, but again, we're capped at 1,250. Okay, so there you can see we've got the same value as we did in the second. Okay, then again, to calculate the expected value, we're taking our contribution and we're timesing it by the probability, and then getting our respective expected values based on the various outcomes, and then we get our average expected value, which is then the 54 687.50 cents. Then we do product 2 and we get our expected values there. It's making sense. No headaches, no question marks here. Everybody happy so far? No questions? Okay, right. So we now have obviously calculated both our outcomes. Now the question is, which alternative are we going to go for? Which one utilizes our machine hours the best? There, just looking at the green and the yellow, oh, you guys can't see all of it. Okay, there we go. Can you guys see?
It's a bit low,
It's a
but
bit,
we'll
yeah.
probably go for the high price alternative.
Yeah, we should. I mean, we're always looking to maximize shareholder wealth, right? So we want the one that's obviously giving us the most. So here we can already see in both scenarios, product 1 does not fully utilize our machine hours like product 2 does. Because in scenario 1, you can see product 2 is 65,000 and product 1 is only 50,000, isn't it? We go to the higher price alternative. And again, there we see product 1 is 54,000 and product 2 is 95,000. Yes.
I'm not sure I understand the statement you just made.
Hmm.
You said product 1's not utilizing all of our machine hours, which is the 50,000, but the second one is.
I was saying no. So what I said was product 1 does not fully utilize our machine hours as product 2 does. So when I say that, I don't mean it's we are fully utilizing the machine hours. However, you get the point.
Yeah.
Okay, I'll leave it then. All right.
This will explain the process of it, like constructing that. So you said the first thing you do is you get the contribution margin per product individual, and then you do the one probably just working through it
To get to the final bit, how to navigate. Okay, no problem. So can we just finish off this last bit, because the last bit was to put commentary. So I'm sure by now we all realize we are going with product 2. Okay, so your commentary should follow along the lines of the above analysis indicates that product 2 will be more profitable than product 1, irrespective of the price set. Okay, there are numerous ways of you guys expressing that. So we're not expecting you to use the exact same wording, but the whole point is product 1 is more profitable. It gives us a bigger return than that of product 1 for our returns under both scenarios. So I think the thing that most students might have forgotten with this particular question is to have actually mentioned irrespective of the price set, irrespective of the or lower alternative or the higher alternative. I think once you look at the amounts, you would have known now product 2 is the one that's yielding the most return for us or giving us the biggest bang for our buck. So just take note of that. Okay. To speak to both alternatives. Now, speaking to the gentleman's question there as to the steps. So I'm just going to quickly say this. This is where we catch you out on finance, or at least from the way that I've seen how they approach the questions is we ask the question slightly differently. So the steps are always the same, but sometimes you're forced to go into step 2 before you go into step 1. So I would always start by calculating the contribution margin, right? As I highlighted earlier. But here we see you actually needed to first get the total limits in terms of how many units you can produce.
That maximum production possible.
Yes, 100%. You see, so they first calculated the variable cost, right? Because they knew at some point we're going to have to calculate the contribution margin. So we can just keep step one at contribution margin per product, okay? Then you're going to need to check to see what is the maximum possible production with the limiting factor, all right, for each of the products. Then you're going to calculate for your expected value for each of the products under the 2 or more alternatives. I don't think they'll give you more than 2 alternatives though. Okay. And then final step, you can say compare or evaluate returns or profitability of the respective products.
Just repeat that last question.
So the last step, you can say compare or evaluate the return or profitability of respective products.
And so the expected value is just contribution times the weight.
Contribution times your weighting. Yes.
So,
Yeah. And then maybe just put an NB there somewhere just to highlight. Remember to check capacity. And you should be fine. Okay. You guys will see that this learning unit is actually pretty good. I think the only thing that can be challenging is decision trees. But this is why I gave you that upfront to say, I want you to go and try it at home. Then on Wednesday when I see you, we do it together. If you don't go and do it, trust me, it's going to be one of those things where you might have questions around decision trees that you won't get a chance to ask because you didn't actually attempt it and apply your mind to it before us doing it together. But when we do it together, it'll be like, okay, this is what I need to be mindful of. Because I can tell you now, there's a step, I don't want to get into it now, but if you go wrong there, everything that follows is going to be a disaster. Or let me be kind and say, is likely to be a disaster. Okay? And the good part is, if you get that bit right, then you know these are my marks. So, as long as you're mindful of that, trust me, you'll be a very happy camper. Okay, so that was 6.1. Nice little introduction to your decision trees. All right, when we come back, we're gonna do question 6.2, and then we will call it a day.